Okay, so I think we can start this EuroStruct live talk. This is a first of a series of live talks that EuroStruct just launched today. And for those that are not aware, EuroStruct is a European Association for Quality Control of Bridges and Structures. And this association came up from previous cost action called 1406 on quality control of roadway bridges. And you can get more information about this association on our website. And the idea of these talks is to cover some relevant topics that we, as civil engineers and structural engineers mostly, we are dealing with, both from academics to practitioners. And this way, I think it's very relevant to start with our first talk with Professor Rade Hajdin, which was one of the mentors of COST 1406. So I think it was very important for starting this talk. So we have with us Professor Rade, and also the person that is moderating with me, Irina Stepanovic, which was the leader of Working Group 2 and also another mentor of Cost Action 1406. And I hope that in the next hour we'll be very happy to discuss some issues, but also there are some roles. The first one, I will gonna ask you to turn off your cameras. This is a matter of Wi-Fi connection and so on, and also your micros are turned off, as you can see. If you want to put any question during the discussion and so on, myself and Irina, we're gonna see it on the chat. You need to put the questions on the chat, and we are seeing jointly the chat from Zoom and also in Facebook, and we will place this question to our esteemed guest. So I hope that you enjoy and this EuroStruct live talk. And now I will ask Irina to present our guest today.
Hello, everybody. So today the speech will be given by Professor Rade Hajdin. Rade has a PhD degree from ETH from Zurich, and after 7 years working in a private industry, Rade was appointed as visiting associate professor at the University of Pennsylvania. From 2003, Rade is the president of Infrastructure Management Consultants, which is located in Switzerland. And Rade is also a visiting professor at University of Belgrade, responsible for PhD mentoring and consulting public enterprise roads of Serbia. Rade is very active in professional societies, chairing a technical committee for civil and geotechnical engineers at the Swiss Association of Transport Professionals. Also a long-term active member of TRB, YABMAS, IAPSE, ASC, American Society of Civil Engineers, and also ISO 55000 at the Swiss Committee for Standardization. So this is a short introduction. If I missed anything, Rade, you can of course add. And we wish you a very good speech, and also to all the participants, we hope it will all work well and we can chat afterwards.
Irina, thank you very much for the kind introduction. There is a slight difference there. I'm actually full professor in Belgrade, not visiting, but this is okay. And I'm going now to share the screen. I hope you guys are going to be able to see it. If you don't, please react. This is, of course, the premiere for EuroStruct to have a live talk, and I hope that you can see my screen. I would appreciate if Jose and Irina can confirm that, then I can actually start. It's really a pleasure to, is it okay, Irina?
Confirm.
Yeah, yes, okay. Yes, confirm.
It's really a pleasure to have an opportunity here to present some thoughts on the lesson from bridge collapses. Of course, this is a little bit of classical theme, a classical topic. It's been said that you learn more from the collapses or failures than you learn from the successful designs. which is probably an overrated statement, but nevertheless, we can do indeed learn something about bridges and our procedures within a bridge construction operation and retrofitting with regard to the bridge collapses. Now, I'm going to restrain myself to the minority of bridge collapses which are during the service. So I'm not going to talk anything about the collapses during construction, although there are a majority of collapses that we recorded until today. There is also a database on that, so you might also look into it and see that the construction failures are majority, but I'm not going to talk about that. I'm going to talk about the failures during the service, which is in some view also from the TU 1406, because we there dealt with existing bridges. Now, my talk is going to be structured as follows, and I hope this is going to work. Yes. After a short introduction, I'm going to pick up 3 recent failures that during the service. I'm going to talk about the inspection practice and perhaps some of the deficits of the inspection practice today. And finally, I'm going to go to the conclusions. Now, if you talk about failures in a service, the mother of all these failures is the one that is here presented. We are in June 14, 1891, and there was this failure of the railway bridge near Basel, Münchenstein. That was a wrought iron bridge commissioned in 1874, damaged in the flood of 1881, repaired and strengthened in 1881 and 1890. Look at that, 1890 was strengthened, and 1891 there was a failure. 73 people died, unfortunately, and the cause of this failure was a buckling of diagonal members in the middle of the span. So not there where the forces are the largest, but on the contrary, where the forces are lowest in diagonal members. So this buckled, and you can see here probably in this picture, this particular member, where it's probably going to work. Yeah, this particular member here, that's the one that actually buckled first, and then later on, the whole structure buckled on the other side as well. So this is something that that was the beginning of looking into the failures. And of course, we did learn quite a few things from these failures. First of all, we learned that we have to do something about that, and the Swiss parliament, or the Swiss government, was very fast. In 1892, they produced an ordinance on calculation and testing of iron bridges for Swiss railways, and this was actually obligatory, was compulsory ordinance that should be used also for design and also for the testing of the bridges. And testing here could be understood really also inspection as well. Of course, there was also political backlash. The political backlash was that the people were talking in the national parliament about nationalization of railways, something that we today also may have heard about when something happens with regard to our infrastructure. It didn't happen in the end. The railway stayed private, the one. But then after that, some serious work has been started, in particular on the Swiss Federal Institute of Technology, where Professor Tettmeyer was investigating buckling behavior of this particular bridge. And you probably all know about Tettmeyer's line here, which is presented here as well. Oh, I'm sorry for that one. So this one here, this line here, that's a famous Tettmeyer line. And this, of course, is a Euler buckling curve here as well. So this was really something that we learned about. The phenomena of buckling was not well understood until then, and based on this failure, we learned a lot. Now, can we learn something from the recent failures? In the same way as we learned back then from this failure. Now we are going to talk a little bit of that, and there are some differences what we can learn and what we cannot learn. Now, the recent structural failure that I have chosen that are maybe not so arbitrary, but and nevertheless are quite famous. Of course, the first place is August 2018, Polcevera Viaduct in Genoa that failed on August 14. The second one is November 2019, suspension bridge over Tarn near Toulouse in France. And the last one, during also this Corona crisis, in April 2020, bridge over River Magra between Carpiola and Albiano in Tuscany in Italy. Now, are these failure, do we learn the same, can we learn the same thing from this failure as from the one in Basel? Is it some new insight to structural behavior? And I don't think so, really. The causes are well understood, and these bridges are not so complex, and none of the phenomena there were really new with regard to the failure. So what went wrong? What happened there? Why we happen to have these failures? Was it possible to predict these failures? That's a nice question here. And according to inspection preceding the failure, the condition of this bridge was good, all three of them. Actually, also the same thing happened in Münchenstein, where there was also a retrofitting, and after that there was inspection that everything was fine. So maybe something there is not quite as it should be. Let's begin the simplest one of these three. That's a special bridge collapse in Mirepoix-sur-Tarn in France. It was built in 1931, it was renovated completely in 2003, and it was nicely posted to 19 tons, metric tons, of course. Now, what happened there is very simple. The cause of was an overweight truck, allegedly over 50 tons, so that's a gross negligence, and allegedly the same truck passed the bridge several times. So that's the owner of the truck that said that. So anyway, there was something wrong also with the perception or a respect toward the infrastructure if somebody 50 tons go over the bridge 90 tons. This also changed in attitude of our population, also changed regard to infrastructure, which we regard as given, as granted. And then for that reason, we use them as we wish to, so without regard to the posting. That has to be changed as well. Now let's go to the more complex one. The Porchivera Viaduct was constructed in 1967. The stays of two remaining pylons, one pylon has actually collapsed, are strengthened in 1990s, and you might see here in this particular picture here, this strengthening here. In 2017, and that's very significant, the Politecnico di Milano had a report and indicated some suspected behavioral state of the collapsed pylon. I don't have time to go into detail here, but that's something very important because the eigenfrequencies of these stays changed quite significantly. The inspection performed in February 2018 didn't impose any restrictions, but in all fairness, we have to state that the owner of this bridge decided to make an upgrade, and they tendered it in May 2018. Now, they were unlucky about that because the bridge collapsed on August 14, 2018. The last one, the newest one, is the bridge over River Magra. It's constructed in 1809. It was partially destructed in 1945 and was rebuilt in slightly different design in 1949. One thing which is significant here, the concrete slab was added to the structure in 1919, depleting probably safety margin. And through 2013 onward, the population around these two cities, we observed quite a few of cracks on this particular on the pavement of this bridge. The inspection performed in November 2019 didn't reveal any structural deficiency, and the bridge collapsed on April 8, 2020. Okay, so these are the cases here. Now, are there something wrong? As I said before, are inspections actually useless? Now, we had all these three bridges. There was inspection beforehand. Now, let alone the Tarn, which was overloaded. The other two were inspected pretty much within a year of their failure. So is there something wrong with our inspection practice? What do we do in inspection practice? Current practice essentially is documenting damages, which are pretty much only deviation for as new condition. And there is a finally qualitative assessment of safety and serviceability, if at all. Now, I'm not talking each particular country, in each particular practice, there are also differences there. But overall, I think it's fair to say something like that. The structural properties, in particular safety margins, code loading, which was used during design procedure, result of structural analysis, robustness in particular from design phase, this is all knowledge from design phase, are rarely consulted prior or during inspection. Of course, they are consulting in an in-depth investigation, but this is something completely different. This is much more costly activity. This information that I said here needs to be readily available in a structured manner. We have today digitalization. We have all kinds of computers databases. This information has to be on your fingertips. Inspection process, on the other hand, needs not to change much, but inspection results need to be properly interpreted based on the previous knowledge. So there is a conjunction between the previous knowledge on our bridge, the identity card of the bridge, and inspection findings. So inspection are not useless, but they have to be used in a different way. In particular, we got to robustness. Now, when we are talking about these bridges here, both the last two as particular, both Porchivera Viaduct as well the bridge over Marga are really not robust structures. And I'm often being told by several people, my colleagues in particular, that the structural concept of both bridges are now heavily criticized for good reason. And I can agree with that. But let's face it, the bridges that have served well for 75 and 51 years, they shouldn't be just thrown away because their concept is flawed or their concept is heavily criticized. They can be used further on when they are treated properly. So the reason of not being back then in a structural concept was not good enough is not the reason to say that these bridges are useless. They can serve very well if they are treated well. Now, if there's difficulties with that, we can replace them in the due time without letting them to fail. Structural system of both the bridges are quite simple. They are more or less isostatic. And the vulnerable zones that can be triggered overall failure are commonly known. And this particular case is the Porchivera Viaduct, a conflict state, so one member fails and everything fails. And the same thing is the bridge over Magra with the elevated arches. And maybe some of you are not familiar with this last failure, but I'm going to show you what happened there in my view. This could be wrong, but we can talk about that later on. Now, this is a bridge over Marga, a cause of collapse. I'm going to discuss a bit of it. Failure of the first or second, most probably, arch of the side of Capriola is actually the cause of the failure. I think it's the second, but we can discuss about that. The additional slab, maybe, I don't know, but maybe the pressure line was outside of arch core, which is significant enough. And the movement of battens on both sides could also give some additional horizontal force. The cracks in the pavement may induce something like that. Now, my suggestion here is that this bridge failed here and this red point here, okay, due to combined compression and shear. And this part of the arch just fall down. Now I'm going to go further on, just fall down like that, right? Now, there was no equilibrium with the horizontal force of this arch and also of this arch. So this arch also fell down and this tilted. Now there was no anchorage in these columns here. This column tilted, actually freeing the other horizontal truss to tilt as well here, and these arches also fell. So if you look at the final picture of this one, that fits pretty nicely. So this part of just fell very vertically down, and this part, of course, was still connected to the tilted column, if you can see here. Now, this, of course, is not very good if one element is making a progressive failure, but nevertheless, one should take care about these bridges as well, and every sign of the distress should be taken into account and compared with the structural system and the robustness of the same structural system. Now, this is not only a deterioration that is our problem. We have more often than we wish to, we have a problem with the change in actions. Now, the axle loads and the gross vehicle weight are steadily increasing. We have to face that. We are not going to change that. We can probably somehow de-accelerate this trend, but this is not going to change in the future. Also, the number of special transport that require permits are rapidly increasing. So these transport, at least in countries that I know, they are not special anymore because they all the time they be asked for permits. So they are going to stress our bridges. We have to do something also with law enforcement. We have measured some of these way emotions, and we've realized that the legal limits are passed by large margin. And finally, the climate change increased extreme events both in intensity as they need to be taken into account assessed on existing bridges. So it's not only about collecting damages from bridge, it's about the whole picture, and we have to somehow make a inspection 2.0. There is a need to inspection 2.0, and I'm coming to the conclusions. This inspection 2.0 needs a one-time effort before starting inspection to collect the structural information related to bridges, structural system, safety margin, loading, vulnerable areas, robustness. This information needs to be on our fingertips. it cannot be that you go to archive and look for some old plans and this kind of stuff in order to get this information. This has to be there. This is all about digitalization finally. So the BMS, Bridge Management System, the most got the uses and its database component has to be accommodated accordingly. And this is probably a great job to be done, but it has to be done if we want to have a safe infrastructure in the future. And the impact of damages or any other change for that matter must be properly evaluated. And that can be only done if you have an inside knowledge of your structure on your fingertips. Finally, I think that the current trend toward BIM can prove to be quite useful to this end. With regard to that, and I think my time is okay, you can confirm that or not. And of course, I'm ready to take any question you have. Thank you very much for your kind attention.
Thank you, Rade. It was indeed a very interesting talk and a very important topic that I believe for all of us. I will start with the first question, but I would like to inform everybody that you can place your questions on the chat. So the idea is that if you have any questions, you should place in the chat, and myself and Irina will do these questions directly to Professor Rade. So the first question that I want to place to Rade is the following. According to your presentation, this means that owners and managers of bridges, they are investing too much on looking for some elements which are not so critical as it should be, and sometimes they discard, or they may discard, what they should know, or they should know previously as critical elements. Or in other way around, are they not considering what was the concept of these bridges during the design and so on?
Well, I don't want to, of course, to criticize the inspection practice. I think that these people are doing a great job. Finally, we have quite a safe infrastructure here in Europe, and most of the owners are doing a great job. But indeed, everything can be improved, and I think that the current inspection practice is not taking into account all the knowledge that is available about the infrastructure of the objects. And now I can understand completely why the people are doing that. I mean, the cost and time pressure is so high that a lot of people are just going to inspect the bridges, taking care of the damages, putting them in a database, and even evaluate them. So they're looking for and in most cases, structural system is quite obvious. But in some cases, it would be probably valuable if they can have easily available information about the thinking that has governed this bridge design in the past, and maybe some flaws of this design, if they would be recorded in a manner easily accessible to the inspectors. So this is actually my pitch on the whole story. It's not a criticizing of inspection process, which is in most cases quite good, but it's also, enhancing, enriching the inspection processes with the information that is readily available.
Okay, I can maybe, because I immediately continue. So I wanted to ask you actually, how do you foresee future inspections? Meaning, you mentioned digitalization of bridges. So, and you said now enhancing the inspections with already available information. So can you tell us which precisely information you think it's most important, or how the inspections should be enriched in the future?
Well, the most important information is, of course, the loading we use in design phase or in verification phase. If there is some kind of later recalculation of the bridge or structure analysis, reanalysis of the bridge, then this information should be clearly recorded. So you have to know what kind of the action has been taken into account in order to design this bridge. This is something that is probably quite easily can be done in the most of the bridge management systems, and some of them even do have that. The second thing is, of course, a structural system being used. I mean, Of course, there are different software and different input data, but we are doing quite a significant effort to standardize this how to introduce structural system, and this can be also in a structural way put into the database. But I think the most important stuff are so-called vulnerable areas, so that give insight of the inspector where to look when they are doing inspection, which kind of damage can be really significant. Now, I'm maybe with regard to Bridge of Magra, I did quite a lot of studying of these pictures. There is indication there was something on the foot of this arch. There was some damage there if you look carefully in this picture. So this kind of thing should be alarmed already, that something should be done, because this is really vulnerable area. The payment which has been investigated is definitely worthwhile investigating, but the crack in payment is only a symptom. It's not actually the thing that is going to produce a failure. I don't know whether that's answer your question.
Okay, thank you, Rade. Again, for those, I know that someone put the hand in, but you need to use the chat to place the questions. So if you want to place any questions, please use the chat. Another question I want to do it for you, Rade, is the following. We know that we all live in a very special period now. And one of the bridges that you shown was a collapse during this period, especially in Italy. That was fortunately was one of the most affected countries in Europe. My question is, in terms of inspection practices and investment on the management, do you think that there is any impact or any correlation between the period that we are living nowadays and the needs for inspection? Because I believe that from the owner side there was a little bit some kind of safety measures that they did not proceed with some of the inspections that were supposed to do because of the situation we live. Do you have any numbers or any in terms of practice about that? Or
are you referring to Corona, right? To our
yes,
lockdown,
to the pandemic situation. Yeah.
Yeah. Well, actually, the opposite. I mean, given that if you inspect bridges, you are outside of the cities and somewhere in a area which you can maintain the distance of 2 or 3 meters. Actually, we didn't, at least this country didn't affect inspection procedures at all. On the contrary, there was some acceleration with regard to that. I think it was also a good idea to do some repair work during this Corona time. But I didn't experience myself, and I'm not aware of that somebody actually just postponed inspection because of the Corona situation. That's what I can say about that. But I think there is another thing that should be taken care of. I think that the respect for the infrastructure from the 1890s or the founding times of our industrial nations actually went down slowly toward our time, and most of the people take infrastructure granted. The one that happened in Tarn in France is really showing a negligence, even disrespect toward the infrastructure. Yeah, that's what my pitch on that one.
Okay, Irina.
There is a comment from colleague from University of Eiffel on We in Motion. Is it? I'm just reading it right now. Maybe it's. So after the collapse of the Mirepoix, if I read it rightly, bridge in France, we are considering to speed up an ongoing program planning to implement direct enforcement of overload by We in Motion. There are quite a lot of progress in We in Motion for a direct enforcement in several countries and above all in the EU. As Vice President of Science of International Society of We in Motion, we plan to push forward that activity or that initiative.
That's very good, yeah.
Yeah.
And it's the same thing is going to happen probably in this country as well. We are now working also on a research project with regard to the loading, and weighing motion is very important in this way. I think it should be enforced, and also the fines should be much higher than they are now. Yeah.
Okay, I also have here another comment concerning the potential of structural monitoring systems in terms of monitoring these vulnerable areas that you just mentioned, and in the optimal situation, how a digital twin of all the bridges could be used in order to automatically evaluate such data.
Well, I think that BIM, or a digital twin, as you said, is a very, very important development. And if you look into the IFC effort, it's also there that you can also model the structural system, which I find very, very useful. However, said that, I don't think that the structural health monitoring connected to these vulnerable areas, if properly applied, is very valuable, and this thing should be pushed forward, in particular in the cases where robustness of our old bridges, and they are still okay, is robustness is low. So this is something that I think is very important. However, I'm a bit skeptical with regard to these automatics, right? It could be done, of course, and there should be, maybe even in some cases, it's useful to have automatic alarm if something going on. In some countries, they already have that. But with regard to the damages that are not have a direct impact on failures, a careful look by a structural engineer would be also quite helpful, I believe.
Okay, so we have a next question from colleague Mufai Buhari. I'll try from Japan. So the question is, since there are so many old bridges around the world, each bridge should undergo this for structural audit or inspection, which is kind of time-consuming way. Is there any modern technology to overcome that problem?
Well, actually, I tried to say that if you structure data in the proper way, this effort can be significantly reduced. Now, one of the main points, and we do that all the time, is if you go to the archive and look for the data, you lose probably 30% of time, of the overall time that you need to reevaluate the bridge. So if you would have this structured data on your fingertips, on bridge management systems, something like that, you can significantly reduce this effort. And also you can make a triage, you have sort out the bridges that are robust and you don't care about that anymore, and look for the bridges that really can pose a threat to the society. So I think this is something that can help a lot. Yeah. Okay,
Rade, there are here also one question concerning the bridge in Genova. We all know about, if you could provide also some more information about with respect to corrosion and so on. But I will also to add to this question one more thing. We know there was some similar problems with again with a similar typology bridge in Venezuela, which were used the same typology. Why, or would it much more be fruitful if we could exchange some of this information among the managers and operators? Because I think it would be, if we have this information beforehand, I think we could avoid, or at least we could go directly again to these vulnerable areas and make a more strict monitoring of these zones. So if you can speak a little about Genova and how can we use previous information from near faults and even faults for those bridges that we have in our stock, it will be interesting.
Okay. Well, maybe first regarding Genova. Of course, this is something that I only read. I have my opinion on that, and I have to constrain myself to think that are maybe proven. There was a corrosion in a stays. There was also some cracks in a state that are supposed to be fully pre-stressed, which is in itself a kind of a warning sign. There was also these measurements for Tecnico di Milano, which measure the lower frequencies in the stays. So all these signs are quite clear. Now, the direct cause of failure, one can speculate it. Yes, it could be that the stay start to vibrate in a wind, and this, of course, then produce a fatigue failure. But I don't think that it really is so much important. We shouldn't have been that far at first place, so that we are kind of dependent whether there is a storm or no storm. That's the issue. So with regard to the exchange of information, I think that the good structural engineers do know where there are vulnerable places. There are very few structural systems that we don't understand fully. There are some, of course, but there are very few of them. And in particular, the old bridges we do understand them. So it's more about identifying them and putting them in the right perspective together with inspection, putting them together and figure out whether there is a danger or not. The exchange information about failures is a very tricky one. It's a sensitive issue. The people don't want to talk about that, and I can understand that very well. I was moderating back then in Structural Engineering International, YAPSE, a journal. I was moderating the session of lessons from structural failures, and I can tell you this was a very hard job to get any information whatsoever. So this is something that people don't want, and also there are the legal implications, this kind of stuff. So this is the things that people are not very ready to exchange, and I can understand that. But after some time, like for example, Münchenstein Bridge for 1891, now we have all the information after the legal procedures, and we can understand what's going on there. But I don't think that our big problem today is that we don't understand structural behavior. We just don't use the full information in order to figure out that something can happen.
Okay, we have a next question. So based on your experience, or have you seen any case of failure in the joints connected by bolts? Or do you know if it is a common case compared to the other cases?
I'm not really expert on steel, right? So that I cannot do that. But there are quite a few, of course, these failures. Silver's Bridge in US in 1967 that actually was triggering the NBI initiative, right? Was one that this I bar with a bolt actually was failed. So this one I know. There are quite a few of these things as well with the old bridges, in particular riveted bridges that have a failure. But in itself, very few of these bridges fail because of one rivet that failed there or a bolt. So if that would be the case, that is indeed a very, very significant thing that should be inspected. If you are reliable only on one bolt.
Rade, another question that is here is about the inspection 2.0 or the digitalization and so on. Is there any asset managers actually using inspection 2.0 as it should be and or really well? And in your opinion, who are in the right way according to your experience?
I don't want to throw names, but I think that there are some significant effort in Holland, also Germany, and also here in Switzerland. I know the Austrians are also going this direction. So there is some effort along these lines, but this is not complete. It's not exhaustive. I don't have insight in all other administration. I'm not talking about research. Research is a different story. I'm talking about really authorities. So I cannot say for sure. I know that in Japan there is quite a few work being done in this direction. So we are moving toward it. I'm quite confident this is going to happen in due time. And again, back to digital twin. I think digital twin can also help to this regard.
We have one comment about the Polcevera bridge. So a colleague agrees that it is also the point about the robustness and how structural system is selected. So for example, in Polcevera viaduct, it has been difficult to evaluate the condition of stays because they are quite unique. It's not a question, more the comment.
Yeah, they are unique, but nevertheless, we don't want to criticize. That's what I say. I don't like these remarks. Well, these systems, your concept is flawed. Their concept is not okay. Or that's our heritage, and we have to keep to our heritage. And you know, if there are also bridges from medieval times that also have some flaws, perhaps, and we are sticking to it, and that's what we have to do as well.
We have also here a question concerning the Magra Bridge and the cause of collapse. How do we know that is not undermining of the foundations? There were some movements on the abutments, and the bridge piers tilt. So
the bridge pier tilt, the one that they tilt, that are quite clear due to the failure. The one that didn't tilt was one of the first piers being done in Italy, to my knowledge, that was pneumatic caisson. So that's very, very strong pier. That one in the river itself. And the problem with that was, of course, that the column on the foundation, which is caisson foundation, right? Pneumatic caisson, which you know, that doesn't move at all. That the pier itself was not anchored. So this was just, you know, a masonry, and this actually produced the movement, right? So the middle pier, the one that we are talking about, first moved toward left and then moved to right and then stayed put. Where the other one, the other pier, all other piers toward the side of Albiano actually tilted.
Maybe it's a good moment to, I don't see any question there, so, but it triggers me when we are talking about the abutments and foundation. I know you have done some work on scour, so there have been significant failures, also you didn't mention them, but significant failures of bridges due to the scour of...
That's true.
Yeah, so, and as far we have done some research in some projects, also the inspection guidelines or standards regarding the scour inspections or detection are quite weak, we could say. So what would be your comment or suggestion? And it seems one of the most important actually failure mechanisms.
Yes, well, you're completely right. If you look at the statistics of existing bridges, so the bridges in service that failed, then the majority, based on the New York State DOT that collected data on the bridges, not only New York State but also U.S. and worldwide, the majority of them are due to the hydraulic action, hydraulic of any kind, not only scour. And the scour indeed is a big problem, and it's if you compare, for example, scour as a cause of failures and compare it to earthquakes, you will see that scour is much higher. So we have to do something about that. Now, I do believe that the scour inspection can be improved, and they are done mostly in most countries. They are very, very, they're quite an effort to find the scour. But also there, we have to distinguish between the foundation that have piles or caissons, which are very deep, right? And the one that have a shallow foundation. I would concentrate, of course, on shallow foundations. And the most of old bridges, existing bridges, have shallow foundation, unfortunately, because you can remember that the caisson itself is a very expensive way to do foundation. It's also very dangerous for the people working in it, as you know. So that's the reason why there are not very many of them. So most people try to do shallow foundation, also the newer bridges, and these are, of course, susceptible to scour, and there the inspection has to be done on a regular basis. Otherwise, we have a problem there as well.
Rade, there are here some questions, and I think I can resume some of them about the importance, of course, of using NDTs and especially the GPR or ground penetrating radar, and also there is another question about the using of structural monitoring systems, how this can be beneficial for the owners, for decision makers, mostly now because we have so cheap systems and sensors that can be much more easily implemented than in before. So, what is your opinion of using this kind of technologies?
I'm all for it, actually. Also the question of the value information. I wouldn't go that far to invest a lot of money in the frame bridge, which has a span of 3 meters, right? I would go for it in there where really it matters. But I would put in the first place, I think VIM or the wave motion on the bridges, not only in the payment, on the bridges itself is very important stuff. And we have this technology now, and this is something that can help a lot to understand where are actually the failures. I would, for example, that's my suggestion, I would measure the reactions in the supports, in bearings. I will measure that anytime possible, because these things can be measured, and you can of course trace back the forces where they go through by knowing the reactions. So this is something that I believe was the first thing. There are other things that I believe was very important, in particular the one that you mentioned, structural health monitoring, generally putting the strain gauge in the right place, using ground penetration radar, in particular for the slabs, where they are, of course, the susceptible to failure. These all things are very variable, and but we have to watch out that they also themselves need some kind of maintenance. If we want to be sure that they deliver us good data, we have also to maintain them. So this is also an issue that should be taken into account. There is also power supply issue, this kind of stuff that you all know, people. And this is everything nice in research area, but if you want to do it 20 years in a row and don't take care of them all the time, but just measure, then there are some other challenges to be overcome.
Okay, we have another question, which is, I think we have done quite some effort in COST TU 1406 in that regard. So how do you envisage in the future the cross-agency approach or in Europe a standardized approach towards bridge inspections? And can we expect that it will be unified in the near future? And also, can we apply the same methods to inspect road and rail bridges and also different types of bridges?
Well, to be quite honest to you, I don't think that I don't know what you think on the short term, right? But if you're thinking about a decade or so, I don't think this is going to happen. It's going to move toward this goal. I mean, there are entrenched practices, and some of them are really not bad, and people are not very eager to change them. So what I firmly believe is that we are going to move toward it, right? There is going to be slow progress toward enhancing database, enhancing our knowledge about the existing structure, collecting new data, and finally we are going to reach that phase that the inspectors, qualified inspector, can have on their fingertips all possible threats and all possible findings that has been done in the past, including structural system, and based on that decide upon what should be done. Now, this doesn't mean that we should keep old structure at any price. Not at all. It means that we have a good decision to be made before something happens, right? And so I don't think it's going to be fast, but it's going to happen in due time.
Rade, we spoke before about weight in motion. There is here a question concerning if the technology that we have today, is it enough to get the OIML certification for weight in motion, especially for overload enforcement?
I think it is, yes. I think that's what I know about wave motion. I know quite a few of systems with wave motion, and I think that they are in prime time. I don't think so, yes.
And the other question before I pass my word to Irina is about digitalization. We all know, of course, that there are many projects around concerning the bridge digitalization, but and the digital twins, especially using the digital twins. But the question is, what is state of art, or what needs to be done in order to start applying the digital twins in practice?
Well, first of all, we need a clear standard. I mean, that's and IFC, I think it's something that is going to be used. Now, IFC itself for bridges is still not there. I mean, there is one version that is coming out, but this version is, for example, not treating at all damages, and also even sensor data cannot be really put into the IFC in a proper manner. So this is something that has to be developed. There are also other things, for example, semantic information that we have in bridge management systems that are not really transferred to the IFC. So there are a couple of projects going on now with regard to infrastructure, mostly roads though, not bridges, that are dealing with it. I mean, one of them was Interlink that has been finished, and now we are working itself. My company ourselves, we are working on the research project together with the German colleagues on the IFC usage for bridges, for roads and bridges finally. So there is a lot of work to be done. I mean, we have one side, the asset management system in developed countries, they have a lot of data, semantic data, mostly alphanumerical data on assets. On the other side, we have the three-dimensional models, which are mostly BIM, and these two things have to be put together. And I think there's a trust today. There is a huge movement toward this goal.
Okay, another question was about the responsibilities, I think regarding the assessment and making decisions. So should the solution be maybe a dual responsibility?
That's a very, very good, a very sensitive issue, right? One of the things which is with inspection is there is because it's qualitative assessment, right? There is really not much responsibility behind it. That's one of the things. So you're not really telling that in inspection report, you rarely find something that people say in 4 years this bridge is going to collapse, because they, frankly speaking, don't know. So by making assessment with regard to connecting to the structural system and to the structural analysis, and also to the damages, you have to take a stand as the engineer and say, it's not responsible for me to this bridge to stay like that, it has to be done, or you say, no, everything is fine. So this responsibility, as well as for design of the new bridges, has to be with the engineers. I'm sorry somebody doesn't like to hear that, but nobody else can do that. It's not a matter of politicians or somebody else to decide upon the technical issues with regard to bridges. And about dividing responsibility, yes, its responsibility is divided already by the fact that if the engineer doesn't have enough information, that some information is hidden or not available, of course, then the owner, as it is in the legal proceedings, the case, the owner has to take its part of responsibility as well.
Now, there is also here one question concerning the existing models for structural deterioration in order to predict the lifetime and to avoid the collapse event. How liable and what can we expect from such models nowadays?
Good one. You know, currently when we are talking about deterioration, we are dealing with the so-called statistical models, right? So what we have currently is condition state, and then we have a lot of data from the past on condition state, and we try to fit this data. Of course, this is not very easy, because these data are scattered a lot, and of course they are subjective to a certain extent. But nevertheless, they give us a vague idea how long does it take for a bridge with the vertical damages that can be observed until it should be put out of the service. Now, I don't think that this is good enough. I think that we have to really assess each particular damage with regard, or symptom for that matter. Symptom is not a damage, symptom is just telling you that something is going on in the structure. Symptom damage, we have to figure out what is going on and try to model that by physical processes or chemical processes. There was a lot of work on that. However, this work was being mostly on the corrosion reinforcement or corrosion steel, and being rather localized. So we have somehow to use a method to figure out the impact of damages and also the future development of damages with regard to serviceability and safety. And this is a challenge, I believe. I mean, one of the things that is also quite interesting, to my knowledge, there are not very many tests being done on damaged elements, girders, slabs, and so on. That would be kind of interesting for the academia to take damaged elements and to see what they really are load carrying capacity of these elements. I know some, of course, but not very many.
Okay, there was then again a comment from Bernard Jakob regarding V in motion, and that the technology actually is ready. But the problem is that legal metrology frame, I would say, around the countries. So the international standardization or body will support moving forward.
I'm quite confident that there are a lot of people pushing that.
Yeah. Okay, maybe if I just wanted to continue regarding your last comment. So what you actually are suggesting is that we should do actually really individual inspections of the bridges. So we shouldn't do generalization in a sense. So we had bridges built, let's say, after Second World War, 50s, 60s, and then many bridges would not satisfy today's requirements of Eurocode regarding the loading. So many countries are, I think, now very careful or afraid that they will have to close a large number of bridges because according to the code requirements, they are not satisfying. So what would be your response or advice regarding that?
Well, definitely not. I mean, these bridges are valuable. They are doing their service. In a lot of cases, they can even carry higher loads. So we have to take care of, re-examine them, reassess them, re-engineer them if possible, and figure out whether they can adapt to the current loads. That said, means also that we have to customize also load models. It cannot be like that one size fits all. I mean, we do know that the alpha coefficient of Eurocode are wildly different countries, and so that's a good reason for that, because the traffic is different as well. So that's also a reason why wave motion is very important, because using wave motion, you can figure out what are really loads that that current bridge have to carry. Designing new one, there is not a big deal, because the additional cost of making to be according to the Eurocode, the alpha values of 1.1 or even 1.2 is not a big deal, because it's not going to be much costlier. But with existing bridges and interrupting traffic, you have really to deal with the current state of affairs.
Rade, we are almost in the end. I'm going to place one question, then Irina, and then I will finalize with the last question and with some information. My question is about the problematic of the hazards, of the extreme events that we have also facing all over the world, but there is here a colleague from India saying concerning the problem of the marine structures, or in other way, marine structures, or the bridges which are close to the sea, and maritime, which are maritime, because they do not only have the problem of the storms, but also they have the problem of a big chloride and corrosion process. What measures, what precautions should we need to take care in order to overcome these situations?
Well, as you probably know, Switzerland is a landlocked country, so we don't have sea. So I cannot really tell for sure, but I think one of the issues also with the seawater is that it has also sulfates, if I remember well, and sulfates are of course very dangerous for concrete, not for steel, but also concrete. So one thing that should be done is to protect this structure as far as possible. But now we are talking about new structures. It's quite easy, because they're not quite easy. It's easier because you can hydrophobe them, you can put some kind of coating, and this is not so bad for a current being. With existing structures, I don't think that you can do much, because this aggressive environment is going to harm your structure one way or another. Is probably the best thing to do is to figure out what is the optimal time to replace or to make a renovation of these structures. That's kind of issue, but for that you need to have a timeline. You have to know what is the service life, how far you can go without endangering people. What was your next question? That was one, right? Oh, the extreme events. Well, we are probably going to face extreme events that are both in intensity and frequency is going to be higher. That's what the people are saying. So maybe our design codes should be adapted accordingly, and also for the existing structure. So existing structure, there is no difference between new existing structure with regard to the extreme events. So that we have to take into account. I mean, there was quite a few of these events. One was in Duero, as you remember that, and this thing can happen over again. I don't think that we can have one size fits all solution for this stuff. It has to be done for each particular. We have also to coordinate our work, which we do in our Horizon project, same way with meteorologists, also with the geologists. We have to work together in order to figure out what are the dangers.
Irina.
Yeah, I mean, generally I'm reading the last few comments and the questions. I think we have covered it. So again, the comment and the question was about the subjectivity of the inspections, and that even the experienced experts could give the different evaluation of the structural behavior or assessment. So I think we have covered. So Rade, if you want to comment that, and then Colin Caprani also commented that actually the most important, the missing link is in all our work is between the condition state and the adjustment to capacity, which I think you already very well covered.
I actually addressed that. That's what I said, the impact of the damages to the structural capacity. This is something I think that there is a potential for research as well. With regard to subjectivity, well, you see, one of the nice things about introduction, maybe, I'm not talking about the future, of course, introduction of BIM, is that you can place damages exactly where they are. So if you have a 3D model, and I'd have a student who is working on that, I hope he's also listening to me now, that's feels good. Now, you can, of course, place your damages exactly where they are. And if you do that, then you start to being objective as well. So now somebody else can take a look into it and say, well, I don't think it's going to be like that. It's going to be like that. Now, this is now discussion between the experts and not anymore, whether it's condition state 3 or 4, right? So this is something that I think can increase objectivity as well.
Rade, last question, and then I think I can say Irina to put her last question, and then I will provide some information to everybody. So my question is more about what we did in cost. We did a lot. Now we start EuroStruct. It is 1 year ago that we launched EuroStruct. What, in your opinion, should be done as a next steps in terms of what we did in cost, in terms of quality control of bridges, and what, if you need to enumerate the most relevant things that you need to do further, what, in your opinion, should be done?
Well, I think that, as I told you also before, I believe if you're talking about EuroStruct, it should also really focus upon the inspection assessment procedures, right? This is something that there is a place to do something about that. I mean, there are other organizations doing that as well, but we can also maybe offer courses with regard to inspection, as we did in the cost action, and perhaps search for the possibilities to show what can happen with the structure if you don't do the right inspection procedure. So this is something that I think we can do that. Also, with regard to structural health monitoring and the proper and effective and efficient use of the structural health monitoring devices. I think there is a huge development in this area, and we are going to face in the future really, good priced solutions that we can get much more insight with regard to structural behavior of existing structures. So that would be, in my view, would be the focus. I don't think that we should really focus ourselves to design.
Okay, Irina, last question.
Yeah, I think it rather covered really a large number of questions and topics, and I think you also, my question was about how do you see where we should put the most effort in the future, which you just said in the last sentence. So I let you, Jose, close. I think we have done a lot of questions and rather.
Okay. So first of all, I would like to acknowledge Irina to be here with me today, and Rade, it was very interesting presentation about a very relevant topic, and we covered a lot of issues. I know that many questions are now arising, but we cannot cover all of them. But for sure, it was very, very enthusiastic. And it was also very good to see a lot of friends here together. So it was a possibility to join all of us. Some they were very active also in cost action. Some are new, but a lot of colleagues are here today. I would only like to share with you our next talk. Our next talk will be on next Wednesday. So on the 20th of May at 2 p.m. CET, and our esteemed invited speaker will be Rafael Sachs from Israel. Actually, he is in Cambridge, and he will speak about again digitalization, BIM, and so on. I hope all of you could attend, and we will go to start disseminating the talk today. Also, I would like to inform you, we were discussing about EuroStruct and the training. From if the COVID situation allows us, from September the 2nd to September the 4th, EuroStruct will organize a training school for inspectors, similar to the one that was done in Prague and in Thessaloniki, with the participation of Professor Rade Hajdin and myself, among others. And this training school will be in Dublin, in Ireland. And of course, we are more than invited to register and attend and learn about better inspection procedures. To finalize, I would like also to inform you that next year, from 29th of August to the 1st of September, we are going to organize the first conference from EuroStruct that will be held in Padua. It will be also launched the information about this conference in Padua in Italy very soon in our website. So once again, many thanks to all of you to be here, and special thanks to our esteemed guest, Professor Rade Hajdin, and to my colleague Irina. Thank you very much, and see you next week.
Thank you.